In the notes for 6.2a, we're starting off with some definitions that you might be familiar with. So an acute angle is an angle whose measure is between 0 and 90. Sometimes we just say less than 90. So in the picture, a 40-degree angle is an acute angle because it's less than 90, but it's bigger than 0. A right angle is exactly 90 degrees, and remember that you can tell that it's 90 degrees because the little box will often be drawn in the corner. Obtuse is between 90 and 180, so a 130-degree angle would count as an obtuse angle. And then a straight angle is an angle whose measure is 180 degrees. Sometimes it's hard to tell if something's a straight angle because it looks like a straight line. The angle addition postulate is really similar to the segment addition postulate that we looked at in the notes from 6.1. If you know how big the measure of angle ABC is, so let's say this piece was 50, and then if you know how big the measure of angle CBD is, so let's say this piece right here was 60 degrees, you can figure out how big the measure of angle ABD is, the measure of the whole thing, because you can add the two pieces up. So 50 plus 60 would give you 110. So in the notes for today, we're going to start by practicing by naming some angles, and then once we're done naming them, we'll practice solving for them. In example number 1, it wants us to name the following angle 3 different ways and then tell what kind of angle it is. Notice the note up there in top in red that says that the vertex has to be the middle letter. That's a rule for naming angles. So this angle right here, I could call it angle, that's this marking right here, angle ADC, or I could call it angle CDA, or I could call it angle D. If there's no other angles next to it, you can call it by the letter that's on the vertex, just that one letter. So usually it's 3 letters, but sometimes it can be 1. Based on the picture, this angle looks like an obtuse angle because it looks like it's between 90 and 180. It looks bigger than a right angle, but it's not quite a straight line. And so in the following 3, look at the way that the letters change. This one could be WXY, or it could be YXW, or it could just be angle X because there's no other angles right here. Because of the box in the corner, I know that one's a right angle. On letter C, it could be LKJ or JKL, or it could be angle K. And based on the picture, this one looks like an acute angle because it looks like it's bigger than 0 but less than 90. And then finally for this one, it could be XWY, or it could be YWX, or it could just be angle W. This is a point right here even though it's not drawn on the picture. And based on the picture right here, we would best classify this one as a straight angle because it appears to be a straight line. Once we practice naming angles, we want to be able to solve for them. And so on example number 2, it wants me to find the measure of angle PRS. So it wants me to figure out the whole thing. If I know this piece, PRT, is 81, and if I know that this piece, TRS, is 42, I can add those together to figure out the whole thing. So again, just like the segment addition postulate, part plus part equals whole, the angle addition postulate works the same way. On B, they want me to figure out how big is angle WXZ. So they just want me to figure out this piece right here. On this one, it's still the angle addition postulate, but you need to do subtraction to figure out the piece. Because if the whole thing's 90, and if this part over here is 26, I can do 90 take away 26 to figure out that this piece right here is not 62. It would be 64 degrees for that missing part of that angle right there. So again, just be careful with your subtraction. But this piece minus this piece will give you the leftovers, and that's how big this part of that angle would be. The angle addition postulate can also help us solve for angles when their measures aren't given as just numbers. So look at this one. I don't know how big this piece is. I don't know how big this piece is. It doesn't say that it's been cut in half, but it does say that the measure of angle ABC, ABC is the whole thing, is equal to 94. So like I did before with the segment addition postulate, for this one I can use the angle addition postulate to say that the part of the angle here plus the other part of the angle that I am given is equal to the whole piece of the angle that I have. So part plus part equals whole. So I set up an equation saying that this piece plus this piece, 3x plus 15 plus x plus 7 equals 94, solve for x. And then once I solve for x, I can take what I got for x and I can plug it back into the part that they want me to solve for. In this case, I'm solving to figure out how big is the measure of angle ABD. So ABD is this piece right here. I would take what I got for x, 18, and I would plug it in right here. And so that's how I get the measure of angle ABD. On B, it starts out the same way. with the same kind of picture, except in this one, see that this part's written in red. You have to read the directions and you have to put the numbers onto the picture where they go. So QSR is 3x plus 1, RST is 2x minus 6, and then they tell me that the whole thing QST is 135. So when I solve this one, I'm going to say part plus part equals whole, and then I'll go through and I'll solve from there. So I'm going to start by combining like terms. That'll give me 5x minus 5 is equal to 135. I'll add the 5 to both sides. So I'll get 5x is equal to 140. And then when I divide both sides by 5, I'll get x is equal to 28 as my answer for x. Once I know what x is equal to, it wants me to solve to find RST. So to find the measure of angle RST, I'm going to take the 28 that I just got and I'm going to plug it in for the x right there. So 2 times 28 minus 6, that'll give me 56 minus 6, which will give me 50 degrees as my answer to the question for angle RST. If it wanted you to solve for QSR, you would need to plug the 28 into the other side. On example number 4, this object that's drawn here onto the paper is called a protractor. And it's usually made out of plastic or metal, and it's half a circle, and it shows you the degree markings. So if you notice over here on this side, if you're going on the outside, they're going up by 10. And then if you come over here, and if you go on the inside, they're also going up by 10, but they go the backwards way. And so it lets you measure how big an angle is. If you wanted to figure out how big the angle MLN was, MLN, you would be counting on the outside numbers, because M right here starts at 0, so angle MLN would be equal to 60 degrees. We don't have to say this on our papers, but this would be an acute angle, because it's between 0 and 90. NLP is a little bit trickier. To figure out that this one is 70 degrees, N starts at 60, and then P stops at 130. So you can do 130 take away 60, or if you say that P is at 50 and N is at 120, you could also do 120 take away 50, but no matter which way you figure it out, they both equal 70. That's probably the hardest one out of all 4 of them, because neither side starts at 0. If you do NLQ, you're starting on this side, so you're going to count on the inside numbers, and so NLQ would be 120 degrees, because that's where it would stop, that's where this line would stop. And then MLQ, you don't really have to use the protractor, but it doesn't matter which way you go, outside or inside, that's a straight angle, so that would be 180 degrees. So acute, obtuse, and straight. In the final example, in example number 5, it tells you in the directions to the question that each angle is being bisected. So if you look over here at the picture, these markings also tell you that this piece of the angle is equal to this piece of the angle. Bisected means that it's being cut in half. So you don't know how big this piece is, you don't know how big this piece is, you don't know how big the whole thing is, but you know that these two pieces are equal to each other. So you can say that this piece is equal to this piece. Solving for x on this one gives you x equals 7, and then you're being asked to find the measure of angle KGF. So you plug it into that part. So you'd plug it into the part that it asks you to plug it into. And so for this one, when you solve, you'll get 23 degrees. On example B, it's set up the same way. These little markings in the corner tell us that these two pieces of the angle are congruent, but it also told you in the directions that the angle is being bisected, so that you also know it's congruent, that the pieces are equal that way too. So for this one, I'll say 7x minus 7, this piece is equal to 5x plus 3, and I'll start by going through and solving for x. Remember, there's lots of different ways you can solve for x. This is just one way. And so on this one, when I solve for x, I'm going to get x equals 5. And then I'm being asked to find the measure of angle y, x, z. So it's this piece that I'm looking for. So to solve to figure out the measure of angle y, x, z, I'll have to plug my 5 in right here for x. So 5 times 5 plus 3 gives me 25 plus 3, which would give me 28 degrees. And so the measure of angle YXZ, this piece right here, is equal to 28 degrees.